Dr. P.M.J. Stalin, Professor in the Department of Mechanical Engineering and Additional Control of Examination, Adi Sankara deemed to be University, Gudur, Andhra Pradesh. It's my privilege to introduce our esteemed chief guest for this session, my mentor, my guide, and my philosopher, so Dr. T.V. Arjunan sir, from the Department of Mechanical Engineering at Guru Kasidas Viswavidyalaya, Central University, Class 4. Sir completed his BE in Mechanical Engineering from Anna University, ME in Thermal Engineering from Cornell University, and PhD in the field of solar desalination from Anna University, Chennai. Sir research interests span across innovative solar energy, including solar water heater with nanofluids, solar drying, solar desalination, evacuated tube collector, solar PV, composite material, and hybrid composite material. Dr. Arjunan sir has guided 14 PhD scholars and guiding 5 more scholars ongoing and published over 140 research papers in reputed SCI Scopus Index Journal and conference, having around 4,000 citations to his credits. His contribution include 6 granted patents, 1 book publication, and 7 book chapters in international publications. SAR has organized and coordinated numerous national workshops, FDP, and international conferences. His excellence has also been acknowledged through several prestigious honors such as KF India Memorial Award from the Institution of Engineers and the Best Teacher Award and the Best Paper Award to his credits. Dr. T.V. Arjunan sir has made a significant contribution as principal investigator in several prestigious sponsored research projects worth of 3.5 crores, funded by leading agencies such as MHRD, ACT, TechUp, and DST. With his exceptional combination of academic brilliance, impactful research, funded project, dedicated mentorship, and administrative experience, including serving as a dean, professor, head of the department, he stands as an inspiration in the field of solar thermal system, heat transfer, and solar energy technologies. We are privileged to have him as a resource person with us today. Please join me in extending a warm welcome to Dr. T.V. Arjunan sir to share his insight with us. On behalf of the organizer and all the participants, I extend very warm welcome to you, sir. With these words, now I hand over the session to our esteemed resource person, Professor Dr. T.V. Arjunan sir.
Yeah, thank you, Michael. Thank you for the nice introduction. And, am I audible, na?
Audible, sir. Audible, sir.
Okay, my screen is visible, na? My screen.
Yes, visible, sir.
Okay, so very good evening to all. So first of all, I would like to thank the coordinator, Dr. Manoj and Dr. Michael, for the opportunity given to me. I also thank the management of this university. And today topic is given to me, the harnessing solar thermal energy for industrial decarbonization, innovation driving climate action. This is a very good topic. First of all, for this I thank to the organizer. The topic is very much need of the hour at present. So I am not going to take much time because already we are running late. So I will right away go to the presentations. So what is meant by decarbonization? So it refers to the process of reducing or eliminating the carbon dioxide emissions. So by not only CO2, in other greenhouse gases, normally we call it CHGs from various human activities. So this is called the decarbonization. So this may be related to energy production or from the industry side, transportation and agriculture, etc., where the energy we are consuming. So from that we are getting this kind of CHG gases. So these to be reduced. So this process is called decarbonization. Then it is the key factor addressing the climate change and achieving the global sustainability goals. So that this word is very, very important at present. And industry decarbonization is nothing but the same definition. So it refers to the process of reducing or eliminating carbon dioxide and other greenhouse gases from the industrial activities without compromising productivity or economic growth. This is the definition of industry carbonization. So normally these involves transitioning the industry toward the cleaner energy sources, efficient technologies, sustainable production process. So these from this to achieve the low carbon and net zero emissions. That is what their aim. So particularly out of the industry, there are four or five industries are there. There is the largest contributor of the CO2 emissions. So those industries are the steel, cement, chemicals, oil and gas, aluminum, fertilizers, and manufacturing industries are the largest contributors. So the industry decarbonization aims to make this sector environmentally sustainable while maintaining the competitiveness. So is the industry decarbonization important? So yes, because the industry sector is a vital source of wealth, prosperity, and social value in the global system. Because without industry, we can't survive. So we need the industry, and so you can see industry produces about 1/4 of global GDP and employment, along with roughly 1/4 of the world CNG emissions also. So these CO2 is the most significant gas emitted result of industry activities. So almost half of the CO2 gas comes from the production of four commodities. There is the cement, steel, ammonia, and ethylene, the based industries. So there is one agreement done by the United Nations countries. So it was done in the Paris in the year of 2015. So they have decided that so the agreement is mainly focus on the temperature rising from 2 degrees centigrade and ideally limiting the average temperature rise to 1.5 degrees. So this agreement is mainly states on preventing the average global temperature rise to 2 degree. So we have to reduce to 1.5 degree Celsius. So these all the countries in association with the United Nations member, so they are all agreed to limit this temperature rise within the limit, limits 1.5 degrees. So achieving these goals would require an 80 to 95% reduction of global emissions by 250. So there's what there and so once start the industrial era in between the 1980s. So there the average temperature rise is very minimum. But after that, once the industry era starts, then this average temperature rise is increasing year by year. Now we are almost reaching 1.5 degree. So because of this is it is threatening the globe. So because of that, the United Nations member, they have decided that we have to take some alternate measure to reduce this global emission to where to save our earth. So many decisions they have taken. So we have to introduce renewable energy based fuels quickly, and we have to shut off different one of the thermal power plants. You can find in many countries they have already started to close the thermal power plants. So they started with the renewable energy based fuels. So these are all based on the agreement done by the UN members in 2015 at Paris. So how to achieve these industrial decarbonization? There are different ways. So first is the transition to renewable energy. We have to change. So we have to replace the fossil fuel with clean and renewable energy sources. There are a number of renewable energy sources are nowadays they are promoting that it's coming up. So out of this, solar is the major contribution of all other compared to other renewable energies such as wind, hydro, biomass, and geothermal. So apart from that, we have to improve the energy efficiency, electrification of industrial process. Wherever directly we are using fossil fuel, we have to convert that into the electrification and adoption of green hydrogen. That is another important topic. Is nowadays the people are talking more number. And carbon capture, this is also another important topic. So utilization and storage. So these are the these are the solutions for achieving the industrial decarbonization. So today we are going to discuss about only on solar. That is the topics given to me. Solar, particularly solar thermal. So we are going to talk about solar thermal only. So now we coming to the solar energy conversion. So solar energy solar energy is converting in the two form of energy. So one is the electrical energy, another is thermal energy. So everybody knows the electrical energy. Directly we can, with the help of photovoltaic cell, we can convert that radiation energy into direct electrical energy. That's all. That is, we can send that energy for the users. So this is everybody knows. Then another kind of energy is called thermal energy. So thermal energy is that radiation energy is converted. So this one. Sorry for that. So this is the energy, solar thermal energy. So this is the collector where this converting the radiation energy into the thermal energy. So this is a sample collector for this solar thermal application. So where the solar radiation it fall on the surface here. So this is called an observer. This observer, what will do? It absorbs that radiation and it's converted into heat. So this heat energy is available here. Then where the fluid, so there is some water or any air, some fluids they are passing through this observer plate to extract the heat. So the heat fluid we can utilize for the purpose. This is the solar thermal, the simple basic principle. So there are classification of thermal collector. So we have basically non-concentrating and concentrating type. There are two types of classification. So under non-concentrating type, you can see flat plate collector, evacuated tube collector, and PVT collectors. And you can see the concentrating type. You find out parabolic trough collector, collisative field collectors, linear fresnel collectors, parabolic collectors collector, and concentrating. So these are the, so this is the flat plate collector, this is the evacuated tube collector, and you can find this is a tower concept. This is the parabolic trough collector. This is the concentrating parabolic collectors, and these are the different collectors. This is the evacuated the model. So we'll see one by one quickly. And this is the basic classification of solar flat plate collector. So here the flat plate collector basically they're divided into two groups. One is the water heater, another is the air heater. So water heater, the water is the working fluid. The fluid medium is water, whereas in the air heater, this air is the working fluid. So here, to the next one. So this is the basic components of the flat plate water heater. So this is, you can see there are the glass cover, and there is a copper tube where the fluid is passing through this tube, and this is the bottom surface is the observer plate, and there is the insulation. There is the insulation is the purpose is to reduce the heat loss from the system to the surroundings, and the aluminum casing. There is a to cover entire casing. These are the 5 important components in the flat plate solar water heater. So now, see here, so when the radiation strikes in the flat plate collector, so then so this is the glass, it is a transparent glass. Then the radiation is after transferring from here, then it directly contact with the surface. So there, that radiation energy is converted into thermal energy. That energy is transferred to this copper tube. where the water is flowing through inside. So then when it's travel, this water is getting heated, that water is collecting outside. This is the working principle of this flood plate collector. So here you can see there are two types of solar water heating system. One is the thermosiphon system, another is the active system. So thermosiphon system, if you see most of the houses, you can see this kind of thermosiphon system only. So here what will happen, the water is coming from the main tank to this solar tank. So here this water is going through the inlet to the system through the inlet pipe. Then initially it is filled by this cold water. Then once sunrise starts, then the radiation comes in contact with the surface. Then this radiation is converted into heat energy. That heat energy is transferred to this water available in this surface. So what will happen then, when the temperature rise, then this water density gets getting lower. So that what will happen, so the cold water available in the tank is the density of, compared to this is low. So what will happen, this higher density water try to come lower the downward, then the low density water moves upward direction. Like that, the hot water moves upper direction, cold water comes in the lower direction. Then again it gets heated because of that temperature heating. Then again this hot water moves up, the cold water comes. Like that, this is called the natural circulation. Natural circulation, the hot water moves in the top surface of the tank where we are taking the water for the application. So this is the simple working principle of thermosiphon water heating system. So then this is another kind of system. It's called active system. Here, the similar kind of principle, but the thing is there is two water circuits are there. One is the water which is flowing through the system, and another thing is the water is flowing for the application side. So here you see this is a water is entering enter this direction. From the cold water enter this, and it takes the heat from this surface and it goes directly to the applications here. So here what will happen, this particular this place, the water is circulating through the circulating pump. The cold water first enter into the flood plate collector where it gets heated. Then the hot water is moving here this direction, and it again back to the storage tank in the system. Then here it is the hot water available. Then it transfer heat to the cold water surrounded by this in the tank. Then it release the heat. Then it moves again. It goes to the flood plate collector. It gets heated. Then again come, and this cycle is repeated. So this water doesn't mix with this tank water, but it is circulating and it is transferring, exchanging only the heat which is taking from the flood plate collector. This is a principle of flood plate. So most of the industrial applications are working based on this system only. And another collector is called evacuated tube collector. So evacuated tube collector is a evacuative collector is mostly use the maximum efficiency among the concentrating technologies because of, so it requires less space. There is a lot of advantage over the flood plate collector, and it can be used on the cloudy conditions and cold all the windy days. So because this is the biggest advantage when compared to flood plate collector. And it is a kind of cylindrical tube that has you can see this, it is a cylindrical shape, and it has absorber coating here, and there is a inner and outer tubes are there. In between there is a vacuum space. So vacuum space is the purpose of vacuum space is to reduce the heat loss between the inner surface to the surroundings, so that it act as the vacuum space act as a insulator thing. Then there is a selective coatings also there to observe all the thermal radiation. This is the inside you can find out there is a selective coating, so to observe maximum the radiation available in the site. So once once it is heated, then this heat is transferred through the working fluids. It may be, directly we can send it to this surface, or we can with the help of heat pipe or any other medium we can excite the heat from the surfaces. So you can see this is a, view of the ETC tube. This is the view of ETC tube. And normally it is available in the two diameter. The outside diameter is two types. One is 58 mm, another 47 mm. Then the length of the tube available is 1500 mm and 1800 mm. So these are the materials of the tubes. And you can see here because of this gap is the vacuum. So this is called the selective coating surfaces, and we are getting this much per sunlight is 100%, almost 90.7% we are getting into the surfaces. This is the biggest advantage. Then the working principle of evacuated tube, it is also very similar to the flat plate collector, but slightly different. So you see, this is a water tank. This is a water tank. It is the evacuated tube. It's attached. You might be seeing in the water. If you have the solar water heating in your home, you might be seeing this arrangement. So this solar tank is connected with the evacuated tube. So what will happen then? Once it started, the water is flowing inside the evacuated tube. Then when the sun rays started hitting on this surface, then this surface getting heated. This surface getting heated because there is a selective coating. So this radiation converted into heat here, then that heat is transferred to this water. Because of that, water gets heated. Then the hot water, again the same principle, because this is the hot water, that this is the cold water initially. So this is due to the density difference. This water is try to move downside, and this hot water moves upper side. So this cold water replace the hot water here. Then again that water gets heated. Then again this heated water goes up. So this cycle is repeated. So this is the working principle of a simple solar evacuated tube water heating system. And here you can see this is another system. So with the help of U-tube arrangements. So here you can see, so the same the evacuated tube here. And when the water is entered here, then this water goes through the U-tube. It is a copper tube, and while traveling, so it extracts the heat from the evacuated surface where the heat energy is available. So then it gets heated and it goes to here. So why these concepts came? Suppose this is in the previous case, it is connected with all the tubes here. Suppose due to the natural cause, any one tube is broken, then the water will be going out. So this is the biggest loss every time we have to get it. So, but this is so here those kind of problem is not occur, because if we want tube case, then we can change easily, because there is no water losses and no process disturbed. So this is the advantage over the previous system. And the similar concept for evacuated tube, you can see that one. Here it's called the heat pipe arrangement. So this is the ETC tube. So there is inserted with the heat pipe, where the heat pipe there is one is the evaporation side, another is the condenser side. There are two sections of that. This is a condenser side, this is the evaporation side. So in the heat pipe, the principle of heat pipe is there is a working fluid. There is in the working fluid filled in the heat pipe. When the radiation strikes, that radiation is converted to heat. The heat energy available in this surface, that is transferred to the heat pipe. So then once the heat is receiving, then the fluid available in the heat pipe gets evaporated. So once it is evaporated, it's move upper direction. So the evaporated vapor is available with high temperature here. Then where we are circulating the water from the outside to this through this header. through this header where the heated vapor is available. When the water is contacted with this surface, then it transfers the heat to this water, and because of that the water gets heated. Then we are taking the hot water outside, and when once it releases the heat, this fluid gets again condensed. Then again it's coming back to this the bottom surface, and again it gets heated, and again it's evaporated and goes here and transfer the heat to here. This cycle is repeated. So this is the way the heat is transferred from the evacuated tube to the working fluid. So this is, you can see the pictorial view of the heat pipe is here, and these are the evacuated tube and other. And this is the condenser where the water is contacting this place. These are the arrangements of different combinations. You can see this is the header where the cold water is in. So where this condenser surface is located here, and here the water is moving up. Water vapor is moving this direction. Then it is condensed and coming back. So this cold water takes a heat, and it's going out as a hot water. This is the principle of solar evacuative collector with heat pipe. And this is another technology, is called CST technology. So here you can see there are different types of parabolic trough collector. It's called the PTC. So here you can see this is the parabolic concentrator, parabolic trough collector is there. It is a parabolic shape, and in between there is called it's called absorber tube. This absorber tube will go. So here the working fluid passing through this absorber tube, when the radiation comes, and when it's strikes in the parabolic trough collector, all the radiation is concentrated to this tube. Such a way the absorber tube is designed, the location of absorber tube is designed. So because of that, the working fluid flowing inside the absorber tube gets heated. So this is, we can get around more than 250-degree. The possibilities. There is a high temperature applications for this ESA concentrated solar technologies are using. Then another, you can see this is the linear Fresnel reflector. This is also similar concept. So where this is the working fluid flowing the direction. So this is a curved mirror available surrounding in the area where we are fixing. So the radiation when falling on this mirror is redirected to this the line of contact here, absorber tube. So where the absorber tube gets heated, then it will be used for the application purpose. And another the purpose is the solar tower concept. It's called central receiver system. So this is the solar tower. Normally this is a single point. Then this is surrounded by the heliostats. It's called a mirror. So those mirror, the function of mirror is when the radiation it comes and strikes, then it will redirect this into the solar tower where we are absorber tube and reconcentrator is there. So where the fluid is available, it gets heated. It can produce a very high temperature. Most of the solar power plants, they are running with this kind of collectors. And another thing is called parabolic disc collector. This is particularly solar cooking applications. So they are using this kind of parabolic discs. So here, what are the radiation or fall on this parabolic disc? It is concentrated in the single surface where this is we are keeping the object to heat. So these are the different types of collectors we have seen. We have seen flat plate collector, evacuative collectors, and different types, and other parabolic linear Fresnel, parabolic disc, and central receiver collector we have seen. Now move to the solar industrial process heat. What is normally is called the SHIP. So what is this? Solar energy potential industries. So normally, almost 40 to 50% of total energy is consumed in industrial sector alone. So if you consider as a whole, out of 100%, nearly 50% of the energy is consumed by the industry sector only. So that's why everybody is any energy crisis or a global warming, what are things happen? Mainly we are focusing on the industry. The main reason behind that is the industry is consuming more than 50% of the energy what we are consuming nowadays. And out of, again, further, if we see out of that 50%, again, the 54% of consumption in thermal form. Thermal form means directly, not electrical form. So they're using in the heat energy for the different applications, the temperature ranging below 250 degree. So these applications are include, you can see drying, finishing in the textile industry. So drying, dissolving, thickening, leaching, distillation in the chemical industries, and cooking, drying, and canning in the food industry. So craft pulping, bleaching, and drying in the pulp and paper industries. So many applications. Many applications are using the heat energy directly without using the electrical energy. So that they are using the fossil fuel for this purpose. So that's why this working fluid required for this application is a pressurized hot water steamer in the temperature range of 660 to 250 degrees Celsius. So that's why a less than 250 degree temperature, no, it is easily we can obtain from the solar thermal technologies. So we can further you see that different industrial process applications for different process for the different industries. Here you see the temperature range. So for drying is required 30 to 90 degree. For the food and beverage industry, for washing is required 60 to 90 degree. So you can see many applications. Only here you can find 500 to 1000 degree. So those kind of things is a little difficult to get from the solar thermal, but the less than 250 degree is quite possible with the help of this collector what we have seen. So only the high temperature side is very a little difficult to get the exact temperature, but the lower temperature side less than 250 degree, there is a great potential to implement the solar thermal applications in the different industries. And you can see the temperature ranges and suitable collectors for SHIPs. So here, if you see the industry, chemical industry, so we need for boiling purpose, we need below 150 degree only. For food and beverage industry, drying, boiling, these pressuring and sterilizing. Similarly, for machinery, cleaning, drying applications, and for mining, copper electrolyte refining, these are the process required only 150 degree. Less than 150 degree only. So this you can easily with the help of flat plate and evacuative collector we can get this temperature. So normally evacuative we can get the temperature around 150 160 degree. And for the medium temperature range is called 150 to 400 degrees. So here you can find a distillation. These are the process. These are the process we can be used this kind of parabolic trough collector and Fresnel collector. So we can utilize for the achieving this range. So 250 degree, and if we go more than 250 degree, then we can go for this concentrating disc collector. And if we want to 350 degree, there is a possible of with the help of parabolic trough collector and the Fresnel collectors. So there is a possible we can go for till 400 degree with the help of solar thermal applications. And you can see the cost wise also. This graph is shown the y-axis is installed cost here, and the x-axis is the temperature range. Range here, if you see the 100 degree up to 150 degrees, so this is a collector. This kind of one glass front plate glass plate collector is sufficient. If we want to 200 less than 180 degree, 150 degree, we can go with evacuative tube collector. And if you want to increase certain level temperature rise, you can go with evacuative tube collector with the CPC. This is a concentrated thing. And from this figure, you can see this is a blue line. It says that 0.7 megawatt, it is 1.5, it is the lower capacity 0.7 it's coming here. So it seems whenever if you increase the capacity of installation, you are getting the lowest installation cost. Overall cost will be reduced. That's what we from this. And you can see 30 to 150 degree is the most cost effective temperature range in which to operate using solar thermal methods. So each line represents a different system capacity. Larger system are more cost effective. So if you go, when you compare to the smaller capacity, if you go with the larger capacity, you will get the cost effective systems. And benchmark cost for different types of concentrating collector is a solar collecting system. This you can see, this is approved by MNRE. A solar collector system for direct heating application is 12,000 per meter squared. And for this, concentrating the manual tracking is, this is a benchmark. It may be vary from a little different place to place. And how the solar thermal technologies for industrial process. The working is, suppose you consider this is an industry. So here, this is the array of floppy collector arrays. So where the working fluid is passing and getting heated. So this water is enter into this field, solar field, and it collect the heat available in the collector, and it is go back to the heat storage unit where the heat is storing here, and that heat is later on it is sent it to the industry back, or otherwise sometime it can be directly sent it to here. Suppose in the night time or not whenever the hot water is not hot heat energy is not required, so they will store heat here. There are excess heat they can store here, and the remaining heat energy is passing through this industry. So it's a simple concept, but in our home applications, we have the capacity of the solar collector is very limited because only 4-5 people we are there. But for industry, we need more number of collectors because the application is vast, so that you can find the number of arrays are more. So the working fluid is passing through this according to the requirement. This is the basic principle of solar thermal technologies. And here you can see the Indian solar thermal market. So over 15 million tons of fuel oil in industry requiring heat up around 250 degrees for annual. This is for annual. See, and 500 trillion units of electricity in various sectors are consumed for heating water and air. So only for heating water and air. So the industry are consuming energy in the different forms, but our focus on solar thermal, particularly heating water and air only. So that if we consider, for that they are spending nearly 15 million tons of fuel oil, even that is less than 250 degrees Celsius. So main application is, you can see the process heat, residential cooking and water heating account more than 90% of the thermal energy requirements. So these at present, the primarily they meet this energy through the coal, biomass and petroleum fuels only. So because of the decarbonization things, we need to replace these fossil fuel with the renewable energy. So this is quite possible, but particularly for solar energy, we can replace with this existing system. So several areas of India is a good direct normal radiance actually, so that it is easily possible to get 250 degree. And even if 1% of this heating energy requirement is met by using concentrated solar thermal, the potential for SHIP estimated to over 2.5 million meters square. So if you effectively use 1% of energy here, so that can be the 2.5 million meters squared. And in spite of all these things, you can see India continues to maintain its position among the top 5 markets for solar thermal globally. So now we are in the top 5 when compared to other country. So SHIP is an upcoming market in India and place it there in the world. So it is going to be. And Indian solar thermal capacity is around 25. So this is every year you can see the average. It is increasing growth we are showing. So it is, when compared to other countries, so we are showing the highest growth rate. So it seems solar thermal technology now booming up in our country. So with the capacity of 232.5 megawatt thermal, India was among the top 10 markets in the concentrated heat technology, along with the Oman and other top industry who are working with this. industry. And when it comes to solar water heating collector capacity operation, India was in sixth position. India was in the sixth position behind China and Brazil. And you can see the sign of growth in Indian solar thermal market. So this is the, you can see compared to 2007-8 and now we in the 2023, you can see the how much uh, growth we shown here. And you can find the mostly dominated by evacuative color. Red color is so that the evacuative collector, yellow color shows the flood plate collector here. And this another one more is called concentrated collector here. So it is a very limited portions are there, and the maximum the market occupied by the evacuative collector because of its simplicity and the cost, and easily we can install, and the weight also very less that it can be installed in the rooftop also. That's why the evacuative dominating the other flood plate collector in the market. And you can see the last year solar thermal development, when you can see our position is the growth is 25% is growth rate in the 2023. That when compared to UK, it shows the 66%, and another the Mozambique is 40%, and followed by our country is 27%. And apart, similarly, some of the industries like Germany and Poland, Cyprus are decreases. Here we can see this point is some, in spite of that, so there are some countries that showing lesser in the solar thermal market because they are focusing on the solar electrical power. That's why that's maybe the reason for reducing this in their country. And global solar process heating application by country March in 2024, you can see the status of our position is here, and this is this many numbers we have installed, and the collector area and the thermal power value is given here. You can see, you can check it, and this is the status of global solar process heat applications in March 2024. And solar heat for industrial process, if you plan greater than 5,000 meters squared installed, you can see the woman is the top level, because the previous also you can find the woman is having a very high number. That's why it's showing in this here. But we are not in the table because it is considering only the industrial process installed more than 5,000 meters square. And annual collector yield and corresponding equivalent CO2 reduction glassed and unglassed water collector operating end of 2020. So you can see here, so this is a country here, and there is a total collector relay installed and the capacity, total capacity installed, the calculate number of systems, how many systems the collector yield, and similarly, so energy, how much energy saving. So because of that, how much CO2 reduction happened. So this is a way they have tabulated the value for different countries. So our country is India. So you can see the data. So this much amount of CO2 reduction, ton of CO2 reduction we have done at the end of 2022. Because of the installing the solar thermal collector, we have achieved this. And in our country, there is a testing agency out there to test the solar thermal process heating. So there are two testing agencies given is there. There is one is the National Institute of Solar Energy, and another one is the Savitribai Phule University of Pune. So these two are the testing agency of approved by the MNRE. And the promoting agency, solar thermal, the promoting agency, there are 4 agencies are there. One is the Solar Thermal Federation of India, STFI. So STFI works towards the larger industry to the industry. So it considers a member with over 80% share of the solar thermal market. So they remain focused on solar thermal industries, and the National Institute of Solar Energy. So these are the promoting agencies. And the Indian Renewable Energy Development Agency, IREDA, So, and another one is the Solar Energy Corporation of India. So these are the agencies, they are promoting solar thermal technology in our country. And limits in the spread of solar thermal use in the India, particularly in industry. So there are some barrier of for industrial process heat. There are industrial process heat system because it is a mandatory of Indian standard has not been implemented. So we have certain guidelines and certain rules and regulations are there for the solar photovoltaic system and subsidies and many things are available. But whereas in the solar thermal, still it is under process. It is not there. So then lack of volume demand creation to achieve economics of scale, and no policy makes it mandatory for industries to meet a certain percentage of heat through sustainable energy. So this is important. So those kind of policy is not available, and lack of technical knowledge with the certified energy auditor knowledge. This is another very important, because when we talk about solar photovoltaic, it is a like pick and plug. So when you purchase the item, then just assemble and install, then we can directly plug the connection will get the electricity. But whereas for solar thermal, we need a very good knowledge in the energy auditing side. So how much energy required, even design of solar thermal system itself, we need some technical knowledge. So that the technical knowledge is lack in this particular side. And lack of awareness among the bankers and financial institutions about the performance, because still the people, if you talk about solar energy, immediately there in their mind it will come solar photovoltaic only. So that is still lack of awareness among the people about the solar thermal technology. Then no policy performance based incentives. So area based subsidy encourages substandard components. So those kind of are not available. Then another thing is the cheap imports of low quality vacuum tube collector, because we are highly rely on the China. So all what are the solar vacuum tube collector we are collecting? So all from the China only. There is no manufacturers available in our country with the quality. So that is also another reason. And so like that, so many like owners are away is there for the implementing this solar thermal technology. And industry potential. So MNRE has from the with the help of GF Unitos, on group of study they have conducted with 25 industries from 2018, assessed the technical and economic market potential. So they want to study what is the potential in our country. So after that, almost 53% of the countries are industries are required the temperature below 100 degree only can be covered within the. So these can be covered with the non-conventional technology. It seems we can use the flat plate collector and evacuator. We can easily achieve these things. Then while more than 47% can only be covered with CST technologies. So operating up to 400 degree. So if you consider this 53% itself, it is a huge potential for the solar thermals in the industry side. And the technical potential of CST there is around 13.18 gigawatt thermal. Then similarly for when the non-concentrated type, you can go that the potential around 27.8 gigawatt thermal. And 13.6 point, this is the potential. So these are based on the conclusion is that there is a great potential of solar thermal application in the industry. And you can see the process wise, it's called the graph of dairy industry. You can see the dairy industry. So you see the temperature requirement for different process. This is the temperature requirement of different process. It's a cooling, cleaning, and sterilizing, and chemical process, evaporations, spray drying, and so you can see the energy consuming here. You can see how much energy they are consuming here. This is so this you can see the maximum 120 degrees. So these different processes 120. This can be easily achievable from the with the help of the flat plate or solar plate collector. So here you can see washing and cleaning. So now they're using the electricity with boiler fuel and furnace fuel is existing, they're using. So the application is hot water. So the temperature required is only 40 to 60 degrees. So this can be easily, we can get it through the simple water heater. Then similarly for pasteurization, here also boiler fuels like furnace oil, rice cracker, the maximum temperature required 70 degree. So this is a process heat application. This can be easily, so like that you can, this is for the hot air, this is a spray drying. So we need hot air with the help of with the temperature in the 120 degree. This is also possible from the solar thermal here flat plate collectors. And you can see this is another, the textile industry. So you can see this is the textile industry. So these are the different processes. These are the different processes, and the energy being used right now, currently used direct fossil fuel or thermal heat only. The temperature requirement you can see 60 to 90 degree, and maximum it is not more than 110 degree. So here you can see these kind of solar thermal can be, we can replace. Recommended solar technology is solar thermal here. So if you replace this technology with this industry, definitely we can reduce the carbon's maximum. CO2 level we can reduce at the maximum. Then similarly, you can see this is a chemical industry, and these are the different process. These are the different process, and this is the applications medium, and this is the temperature range, and we can replace with the solar thermal. We can replace with the solar thermal. Solar thermal is nothing but we can install any one kind of solar collector, thermal collector, that can be replaced with the existing fossil fuel technologies. And this you can see the automotive process. So solar technology mapping the automotive process. Again, these are the process. Press of electric and pneumatic machines, body shop, here paint shop, the pre-treatment process, air conditioning process, and evaporation and drying, different processes here. So the energy fuel now currently using the electricity, they are using electricity, you can see electricity, biofuels, wherever electricity that can be converted in, that can be used with the solar PV system, and wherever the heat energy is required, that can be replaced with the solar thermal system. So this is a recommendation for this industry. And for CST potential, since concentrated solar technology potential is here also for dairy industries, the potential 60% is there, and food processing industries, and we have the huge potential for these industries. So this can be use the solar thermal technologies for these applications. We can reduce the carbon. So now we'll move to the general process of SHIP plant design. So suppose if we want to design, want to install a solar heat industrial process plant, so some systematic way we have to go. So first is the preliminary analysis. Here to identify the potential application based on the basic information about, suppose any industry want to install. Suppose if we have seen many industries, suppose we want to replace those process with the help of solar technology, solar thermal technologies. Then what first we have to do? We have to go and do the preliminary. We cannot directly by either panel and install. We cannot do it because yes, like in the photovoltaic. Here we have to do some basic initial work we have to do before installing the system to identify the potential of say, application based on the basic effort of the end user, energy, particular energy consumption, the location. Location is mainly how much solar radiation availability, all those things, the heat requirements, and current energy cost, how much cost currently they're consuming. And the detailed analysis of heat supply and the heat consuming process, how the heat is they are consuming, what way they're consuming. So these would include information, the site condition, available space on the ground, because how much spaces are available to install the system, whether we have to install in the ground or we have to install on the rooftop. So all those things we have to analyze, assess the general infrastructure of the industry, including water and electricity, including water and electricity, networks, then many things we have to analyze. The next is the system yield simulation and economic modeling. We have to simulate based on the data available, and we have to make some simulation study. The result of simulation, the economics can be calculated. So when you find, then it is economical way, you have to identify and the technical and economic viability. The next step is this identify the design and integration option of the solar system and define the technical and economic conditions, whether we can completely replace with the solar technology or we can integrate with the existing one. So that is for reduce the fuel consumption. So those systems we have to study here. And the system engineering is including the definition of technical requirements to consider the tendering and commissioning stages. And once it is finalized, then we make the tendering and commissioning. So these three aspects will be added, and we have to make tender. And once it's tender finalized, we have to commissioning starts. So the operation and maintenance procedure to be carried out either by external service, so normally a provider, or the installed by the servicing unit for the facilities. And these are some of the system, the important system in the solar thermal technology is a steam boiler. For industrial processes, we need steam boiler, the most common heat supply system in the industry. So the different process directly or indirectly through heat exchanger with the steam. So this is a important system. And pressurized hot water for the low temperature applications, particularly in the 10 to 100 to 120 degree, even hot water, these things. Then thermal oil is another important working fluid for the temperature range up to 350 degrees. Because some of the things we cannot use water, then those places we have to go with the thermal oil. And hot air burners, then the combined heat power. These heat pumps also is another important component, can upgrade the low temperature waste heat to the higher grade. So this is a heat pump technology. Also, it's booming up at present. And this is some integration unit. You can check with the so this is the boiler is here. Boiler is here. So this is, suppose if you want to install this parabolic trough collector, and this how the heat is moving, then when the hot water is moving to the steam drum here, that maybe steam is splitted over in this part, the steam is going directly for the industrial process, then there is the water comes here, then again if it's recycle here, or it is going to here for the feed water. Otherwise we can this water send it to the boiler here, and it gets heated, converted into steam. That steam is mixed here. So this is integration. So suppose we are not getting the sufficient input from the solar radiation, then the system will not affect. So it will operate with the help of existing boiler system. When the radiation is, when we are getting the sun, sufficient sun energy here, so that time, so we can reduce the usage of fuels, all the energy, steam conversion, everything will be done by here, then it is moving here. Whenever it is we are getting the low energy, low solar energies, then this will operate. So that our industrial process will not hamper. This is the integration and the structure of in India, how to make this structure here. And normally it's called beneficiary is called the heat consumer, who is going to be consumed. Is called the customer, who intends to set up the SFG project here. And the supplier, who is the manufacturer or complete the system and maintain it under the stipulated warranty. Then EPC contractor is another person, a registered engineering company that install the complete system. In most of the cases, the supplier will be the EPC contractor. The developer, so developer is called the identify the industry that can use the system. They obtain the system from the supplier and gets commissioned from the EPC contractor. Also arrange for the finance and prepare the detailed project report. He is called the developer. And OEM service provider, normally the supplier or EPC contractor who is maintain the system. This is called OEM service provider. The dealer is the network of supplier and developer for different parts of the country. Then bank or financial institution, they provide the loan. So provides a loan for the project after due diligence, some of also after the equity participations. And the central state government agency, they provide the grant aid and if any as per the available policy. So they will inspect us as per the norms they have done or not, those kind of. The development aid agency is a unilateral multilateral agency that has a country specific program to promote accelerates SHIP technology by providing grant in aid or easy financing. So these are the structure of SHIP project in our country. And this is planning the same thing. It is done in the form of flowchart, so no need to explain again. And you can see the different industrial process heat already installed in the various locations by different suppliers. So this is a one air heating system. Here, so for heating the air around for 40 to 70, 80 degree for some food industries. And you can see the evacuate tube collector here. This is installed in the industry. And you can see the parabolic trough collector is installed in the industry premises. Here you can see the flat plate collector installed in the industry premises here. And you can see the concentrated disc collectors installed in the combination of different. And you can see the linear Fresnel collectors. So you can see the in the lower part, this is called the mirror, and the radiation when it strike to the mirror, then this mirror redirect to this absorber tube where it is available the fluid here. These are some of the photograph view of solar industrial process heat generation, and some of the industries you can see. In the Sona Chaos Steering Limited, Sriperumbudur, they have installed with the solar evacuated tube collector, and the project size is 210 kilowatt thermal, and this is you can see 10,83,600 kilocalorie per day. The energy is they're saving here, and the CO2 option. Offset is you can see 86.4 ton per year because of that, and the fuel saved after installation this plant, so they saved 36,000 liter per year of fuel. And similarly for Wheels India Limited, you can check it. This is capacity is 630 kilowatt thermal, and this much amount of kilocalorie per day they have saved, nearly 1 lakh liter of fuel saved per year, and nearly 260 tons per year of CO2 they have reduced. And similarly for another industry, for Heritage seating system, Huzur, so they have installed this. Because of that, they reduced nearly 156 tons per year. Similarly, for another Mahindra vehicle manufacturing industry, they have installed for their industry processing purpose, they reduce nearly 120 degrees Celsius. They want to heat the hot water on 20 degree. So similarly, there are a lot of potential in the industries. You can install solar thermal technology to reduce the carbon is used for the environment. So this is another industrial applications in the Chile. So they have installed 39,300 meters square collector area, and this is with the help storage tank, 4,000 meters. This is storage tank also there. Wherever the energy gets then stored here, then they will take whenever it's required. So it supplies nearly 85% of process heat, the refined copper. So they're using the purpose of for the refined copper. So nearly 85% of the process heat is using from this solar technology. And another industrial solar application, the textile industry in China. So there also see they provide nearly 55 degrees Celsius preheated water. So for this purpose, they have used nearly 13,000 meter square flat plate collector area they have installed, and then they heated around 100 degrees centigrade to this place. And this is for solar storage system at their company. So where they have installed 1067 meter square flat plate collector to produce cooked home and food in Austria. This is the country is Austria. Include a 60 meter cube water tank to store the solar heat over the weekends. So suppose whenever it is not working, so that heat stored in the storage tank. And this is provided and drying process at 60 degree. So these proprietary collectors. And these are another branded cycle manufacturing in South India. So they have installed to heat the water from 80 degree to 180 degree range. And these are some of the industrial air heating systems installed in the different locations for the even small capacity to the highest capacities, and green energy technology, green energy. So this is for the air heating purpose, and so now the people are started to use for even small capacity, 2 kilowatt, 3 kilowatt, 5 kilowatt, and small farmers also, they got started using air heater for drying their agriculture products. So this is industrial solar heater. Also, this is an industry to heat the agriculture, to dry the agriculture product. For that, they're developing heating the air heater with the help of solar technology. And you can see industrial solar heaters. This is a small system. It's a Burner Private Limited. For the air heating, they are introducing this system, and you can see this is a air heating technology for the in the again solar in the Maharashtra state. And there is some innovation points I am giving. So these factors. So this I'm just moving very fast because this is some innovation point is some the people who are working in the research, they may use this concept. So how to develop the how to increase the efficiency or performance of the solar thermal system. So I may based on the design factor, this slide moves the design factor. So how to, so they have installed so there is some reflector around that. So focus on this is you can some kind of, I'm just moving fast because of lack of time. So this is a flat plate collector with the observer changes here. So you can see the different kind of observer here. So with the help of, we can improve the performance of the system. And similarly for the, you can all the arrangements are with the observer plate temperatures, observer design, they are modified to get the better performance of the system. And similarly for using the observer plate, they are making some different techniques to create to observe more energy. Okay, it's called shoot pinning techniques. And this is another selective observer used in the flood plate. Some observers you can selecting used for improving the absorptivity, and you can see the fluid flow directions. So this is like a spiral, and it's a curvy, and it is a triple pass. So similar way, they are improved the performance of the systems. And another concept is for turbulence while fluid flowing to create the turbulence. So it will increase the heat transfer coefficient. By the way, we can get the performance more. And similarly for this, for interior part, they are fixing the flow side. The fluid is flowing inside. They're creating some kind of disturbance or some kind of velocity enhancer. To in this way, they improve the performance of the system. And you can see the twisted inserted tubes here. So you can see twisted inserted with through thermosiphon solar water heating system. So in this way, they are trying to improve the performance of the system. This is some innovative idea. So they are installed, they're introduced in the system to get more performance, more. Then advanced heat transfer fluids. So the working fluids, how to improve the performance with the help of working fluids. So normally it's called nanofluids. So they introduce nanoparticle with this fluid. They're mixing with the nanoparticle in the fluids. Because of that, they're getting the better performance than compared to others. So this is the fluid preparation. And we can see this is the one done by the coordinator only. So he has done the experiment with the cerium oxide, and with that he has improved the performance of the solar water heating existing solar system with a certain percentage, nearly 25.2% they got, and this is some improved with the percentage when compared to the uh, existing system. And these are the working fluids he has done with aluminum oxide, cerium oxide, and you can see this figure. Then you can find the performance improvement with the help of the nanofluids of the system. And so these are the different nanoparticles with the help of nanoparticles. And these are the different nanoparticles. Then if you mix with the base plates, we are getting the better performance. And apart from that, energy storage material also influence the performance of the system. So there are two type of energy storage, sensible and latent heat of energy storage. So these are the how to fix these. Can see the PCM container this here. And similarly, so these all, if you see, so the PCM material they have installed here. So this is the surface is PCM, how to explain edge storage material. These are the different PCM material. And see, this is another one more. Since you see they are keeping the edge storage material here, and you see the performance difference here with the help of without PCM and with PCM, how the solar water heating system is performing. And these are the similar kind of things. So similarly, these are the different materials. And come to the air heating side. If you see, this is a simple air heater. When you passing the air through this, when it goes out, so there is a inside the air is absorbing the heat. Because of that, it gets heated. So similarly for this, we are having a lot of modification in the design aspect. Is a double pass, and you can use over on, and a lot of modification if we do. So in this way we can improve the performance of the air heating system also. You can see here also in this air heating also you can find the PCM material. So many people have done in the different design aspects, and you can see the different locations and different shape. So anything if you change, there is some changes in the performance they have identified, and you see the different steady roughness on the observer plate. So these are the observer plate roughness. They have made different percents. Then you can see, and one more thing is the photovoltaic thermal collectors. It is a combination of see the solar thermal collector is there. So far we have studied as in photovoltaic. This is a combination of heat and electrical is called photovoltaic thermal system. That is also available nowadays. It is trending. More people are working on this, and it is produced a combination of either air heating or water heating, and with the solar with the electricity. So this is called solar PVT collector. And these are the, you can see here the PV panel is locating here. And this is the solar PV panel is there, and it produces electric energy as well as the heat energy. So that's why it's called PVT. And you can see the in this figure you can see this called that's a PVC arrangement, and this is called here is a PV cell. So air heating also this device will be done air heating as well as the electricity generations. Okay, so this is the way, and enhancement etc. So how to, it's a similar thing. Only thing is this is a different flat plate collector only. So no other things. And this is some Fable attachment is done by our team only. So this is the one Fable attachment. When the water air is flowing this direction while going this way, it is exciting heat and goes. This is the way we have achieved more than 100 degree of air for the industrial applications. So this is another method of to improving the performance of the system, and this all are the how to improve the performance of the existing system. And another drying system is greenhouse dryer. Maybe yesterday, the first day, the Madheswaran maybe thought about this greenhouse dryer. He is the industrialist person. So this is the for in greenhouse dryer for different applications. This is the one the new new technology is coming up. It's called sand battery system. So with the help of sand, they are storing the excess heat energy during the daytime, and whenever is required, we can take it from this for application. So this is one process is now started in the foreign countries, and this is a photovoltaic again generated. And nowadays it is started here, the PV2 heat. Here you can see the word PV2 heat is nothing but normally in the photovoltaic PVC photovoltaic system, we need inverter to convert DC into AC. But this system now they started with working with directly PV connection system coupled direct DC for the rooftop PV panels. Directly it able to heat the water. So that now the trend is started, and particularly in South Africa, you can see that market is booming like anything. So started from 2018, in the 2023, you can see how much it is start the PV2 heat market. So it directly no inverter is required to convert. So this concept is now coming up in here. And there are different innovations in the solar thermal need, because solar thermal is now started. So we need a lot of digitalization and process optimizations as required. And even in the hybrid solar thermal system also required a lot of innovations. And this is the integrated solar thermal system building. So so these things are so this system is cover completely solar, water heating, air heating, even space heating, everything available in the single system. So that's called integrated solar thermal system for building for all. So the such kind of things are available, and this is already we have seen this. This also we have seen. And this is a combination of solar thermal with biomass gasifications. So here with it is a combination of solar tower and biomass system. So we can use this here hot with the help of solar tower hot fluid that can be used for the biomass gasifier for producing the gas. That gas can be used here. This is a concept, and this is also the biomass, the same concept for the different applications. And another solar thermal collector with selective coatings. So there different coatings are to absorb the more energy. So for that the people are still working in this area. And the solar thermal desalination also, there is a huge potential for thermal energy for convert. So nowadays the thermal desalination also, the people are using the fossil fuel for the heating application purpose. That can be replaced with the solar thermal for the desalination purpose. This figure shows that only. And the heat pump technology, already I have told that the heat pump is now coming up. A bitly the people are working, and yeah. So I think Michael. Hello.
Yes, sir. Please, sir.
Michael, yeah. So I have completed my presentation. I hope only 5 minutes I have taken extra. As per the
No
schedule.
issues, sir. No issues.
Yeah. So do you have any queries, or I can ready to answer for that? Any queries from the audience side?
So there is one question from our participants, sir.
Yeah.
The generated heat by solar is contribute to increasing the global rise in temperature. Whether it will rise the global temperature rise, it's not the question, sir.
No. It will not be, because see, the global temperature rise mainly based on the production of emission of CO2 emission. So here the solar energy, there is no point of CO2 emission. No? CO2 emission is happening only from the fossil fuel waste. So when you burn the fossil fuel, so that is the byproduct is greenhouse gas emissions. No? So but in solar heat there is no such emission possibilities. That's why we are replacing that fossil fuel, replacing by with this solar energy.
If any question from the participant side,
One person is asking PVT is emerging now. Yes, it is now emerging. It is the people are now working because nowadays now. So in the window also they are trying to put the PV panel. So many places they are trying now. Now PVT collectors starting coming up in the market also.
So, dear participants, are having the very rich knowledge in the field of solar thermal system. If you have any queries or doubt regarding the research aspect, so kindly ask the research question, please.
so one more question from the participant side, sir. Can
Yes.
storage can CSP, that is concentrated solar power with storage, can support to peak demand support, helping to stabilize grids with high variable PV systems?
Please once again repeat. I am not getting.
Can CSP with storage can support to peak demand period? Can CSP with storage?
Actually, now the people are working mainly on energy storage only. This is the biggest problem. Solar energy has the biggest problem is the energy storage only. Now people are working on the energy storage system. So if you are finding the effective energy storage system, really great. That will be definitely help to the industry. Completely, we can adopt the solar thermal technology. If you are finding the good energy storage device, definitely that will help.
I hope Amit Gupta got answer.
Yes, Manoj?
Yes, sir. Another participant, sir, Mr. Manishekaran, he needs some more information on sand battery system.
Yeah, actually, sand battery system, some foreign country, recently we have found in some foreign country, they have in company itself, they started company to install a sand battery system in the requested industry. Now we are trying, some people we are working then to develop in our conditions. We have to, in India, I think people are not started yet. But there is a great potential. The people, if we want to work, then they can see that industry, how they are doing, and how we can develop at our conditions. We can try. That is I think it is a great potential because already the company started to install the sand battery system in the industry premises.
Thank you, sir. I hope Mr. Manisharan got the answer.
I asked him to contact me. I will try to send that company details. Right now, I don't have that contact details.
So, Manisharan, sir, I hope you got the answer. Any other questions from the participant, please? Please switch on your mic and you can ask, otherwise you can put your queries in the chat box. No more questions, we can wind up the session.
Yeah, I think already we have already 9:10 time. I think some people may be in the sleeping time. Yeah, Michael, you can give my contact details to the participants. Any doubt, they can contact me.
Okay, sir. Sure, sir. Sure.
Okay. Please conclude. Yeah.
So thank you for your nice presentation, sir. So I think hope all the participants enjoyed your presentation. So starting on, sir explained this. What about the global process heat requirement? What is the position of India? How you have to reduce the CO2 emission in the industry? How to integrate with the solar system? Suppose any industries record heat. So how the thermal system, the solar thermal system, you have to apply into the industry. Suppose any industries record solar PV, how to integrate with the industry with the solar PV. Sir explained in solar PV and solar water heater, solar dryer, and heat pump. So all the areas are covered. So what are the possible opportunities? So still so many researchers, if you want to do research in the field of solar thermal system, they can approach SAR also. SAR having the vast experience in the field of solar thermal system. And moreover, the participants, they enjoyed the presentation with respect to solar thermal system. So how to reduce the CO2 emission when you are installing the solar thermal system in the industry. Sorry, explained about the sand battery also. It is a new concept for us also. It is new concept. And moreover, if anyone interested do the research with respect to solar, so I will share the number into the group. You can directly contact sir. Thank you, sir, for your nice presentation.
Thank you, Michael, for the opportunity, and thank you, Manoj.
Thank you, sir.
Yeah. Okay, then I think we can leave. Can I leave?
Yes, sir.
Yes,
Thank
yes,
you, sir. Thank you for your valuable presence, sir. Good night, sir.
Yeah, thank you, Manoj.
Thank you.
Thank you, Michael, and thank you,
Thank you.
participants. Yeah.
So dear participants, now